Right? Now, if you look at, let's go to next, and this just explain what I just explained. Next one, and next, okay. These are the instruments that we use. If you look at exactly what I have discussed, the error term here is not correlated with the Y. Right? The Y that you use as instruments starting from 2. Starting from 1, because T is starting from 3. So you have 3 minus 2. So which means that YI1, right? Which is this one. Right? So it's captured in there, and YI2 captured in there. And the expected value, this means correlation between them equal to 0. So this is what we term as moment conditions. Right? That we look at covariance between error term and instruments, and we impose that covariance to be equal to 0 using that moment conditions. And that's why we call it as GMM, generalized methods of moments. Right? And because we use the first difference, we call first difference GMM. Right? So that's the name coming from, first difference GMM. Right? So that's basically what we get with respect to the moment conditions. And the assumption that we make is that, again, the error term is not autocorrelated, and the explanatory variables are weakly exogenous. And that's what we have assumed before. And that's why we start with the error term, there exists no autocorrelations, and the variable x are weakly exogenous. Right? So that first different GMM. Now, one of the thing that we have when we run regressions, right? If you run using cross-sectional data set, you put many countries together, you put many provinces together, for examples. You know exactly some countries are big, some countries are small, some countries are rich. The same thing with provinces and so on. One of the potential problems when you have cross-sectional unit would be heteroscedasticity, right? Cross-sectional unit. Now, if you have the problem of heteroscedasticity, why not address them from the beginning? Right? Why not address them from the beginning? Because you don't have to test even. Normally, I think all of you have run Horseman test, and you run all other tests in static panel. For example, you find for sure that your assumptions of homoscedasticity will be rejected when you use cross-sectional data set. So why not address that at the beginning? So the first different GMM addressed that by introducing what we term as two-step first different GMM. And that has resulted in two types of estimation using first different GMM, one-step first different GMM, and two-step first different GMM. What is the main difference between those two? The one-step first different GMM assumes that the error terms are homogeneous, homoscedastic. This two-step GMM, they take the error term from the first steps and they construct the variance covariant metric of the error term, which means they compute error terms sigma square for each unit, as well as the covariance between them, and they use that in the estimation in the second step. So which means they incorporate heteroscedasticity in the estimations. So it becomes two steps GMM, or two-step first different GMM. Right? So sometimes you see people say they use two-step. It means that they relax the assumptions of homoscedastic error term. Right? And that's why they do two steps. Right? But there exists one problem with two steps. Now, See, if you look at what I try to inform you is that any step that you have taken in data analysis, you have to be aware of the problems and you have to know how to solve the problems. Right? I will discuss the problem with first different GMM, but now I will look at one step and two steps. One step, the problem is the assumption of homoscedastic errors. How to solve them? Incorporates the difference variance of the error term in the second step and re-estimates. So you get two-step first difference GMM. And once you estimate second step, there exists problem also. And the problem is the standard error is downward bias. Now, if the standard error downward bias, what that means? It means that when you run the test for hypothesis testing, right? For hypothesis testing. Now, how do you run the test? To test the significance, let's say, I want to test delta equal to 0. Again, the alternative hypothesis, delta not equal to 0. You run the test, you use t-test, you get the estimated value of delta, and you get the standard error of delta hat, right? Mm-hmm. And if this downward bias, what it mean? The t-test will be inflated. What that mean? You are going to find significance.
Yeah.
Right? But that significance, we do not know is right or not because this is downward bias. Right? So, for some of you that have read article, have you read this name, Win Major? When people use two steps, they will make correction of the bias here by using Win Major's corrections. I can show you in the articles. Always people use these Win Major corrections in order to estimate the bias, in order to correct the bias. Right? So what do you mean in this case? Right? Normally people use two-step first different GMM. Right? Normally people use two-step first different GMM. Why? Because we can relax the assumptions of homoscedastic error term, but because of that downward bias, we make correction of that bias using Win Major corrections. And that need to be explained when you write your article or when you put in thesis. When you explain those, people, okay, this person know regarding first different GMM. Right? So that's a very important part to put in. Okay? So that first difference. Now, let's take a look at one more thing. Right? What might be the problem of first different GMM? Now, I give you this. Right? I think all of you have taken, you have econometric lanjutan.
Yes.
Yeah, you have advanced econometric, right? And understand in advanced econometric, you study time series.
Yeah. Yeah.
Right? And when you study time series, I understand that you must learn unit root test, the ADF test, Philip-Ron test. Okay, all of you, right, have taken, or not all of you have taken that course yet. Okay, now. Since some of you have taken that course, right? See, because econometric have a lot of statistical theory behind it, right? But then the unfortunate part is that we learn econometric by learning software. So we just know get result, but we do not know exactly what it means, right? Behind it, right? So that's the problem when we do not know something behind it, right? Now, okay, let me ask you this, right? Because these are testing your whether you remember unit root test or not. right? When you conduct unit root tests, right? How do you conduct unit root tests? The most simple way. We take YIT in time series, right? Better in time series. And YT, okay, equal to beta YT minus 1 plus error term. Just put the most simple specifications, right? And then you test the null hypothesis, whether beta equal to 1, right? Or again, the alternative hypothesis, beta less than 1, right? So that's the way that you test. If beta equal to 1, you have what we term as unit roots, and you conclude that the variable is not stationary. Now that's what you do in unit root test, right? If you reject the null hypothesis, then you say that the variable is stationary, right? But in software, when you conduct the test, they do not use this equation directly. They transform the equation first. How they transform? They minus both sides with IT minus 1. So you are going to get changes in YT equal to, let's say, theta YT minus 1, right? Where theta here equal to beta minus 1. Okay? Because they just minus YT minus 1 from both sides of the equations. So this one, B minus 1, and then plus derivative. And they test the same hypothesis, whether theta equal to 0 or theta is less than 0. And if they are equal to 0, we have unit root test, right? Because if beta equal to 1, it means that theta equal to 0. Because theta equal to beta minus 1, right? So if beta less than 1, it means that theta is less than 0. They just transform the equations. Why? Because in any software, when you get statistic, those statistic t-test is to test whether equal to 0 or not, make it easy. So that's why they transform first, so that we can test this one whether equal to 0 or not. Right? Now, going back to what we have here, that as I mentioned, the requirements for instruments is that there must be correlation between what your instruments, right, with the instrument itself. Now, let's take year 3. Year 3, for example, we have Y3 minus Y2. Right? Remember that I put in YI3 minus YI2. And then this one will equal to delta. What instrument that we use here for Y3, Y2 minus Y1, sorry. These are the variables that we want to instruments, right? And these are the instruments that we use, Y1. Right? Remember that the third equations there. Now, plus error term. Okay? So if Y1 is a good instrument for the first difference, theta must be significance, right? But if theta equal to 0, it means that the first difference here are not correlated with Y1. And that violations of the one condition of the instruments. But we understand from unit root test that is that if theta equal to 0, Y has a unit roots. Right? And we understand from here is that is Y have unit root, beta equal to 1, or very highly persistent. Right? When beta closer and closer to 1, we say that the variable is highly persistent. Why? Because the past value embedded fully in the future value. So when future value depends almost 100% on the past value. Highly persistent variables. But that highly persistent variable make theta to be small, because the closer beta equal to 1, the closer this one equal to 0, which make these two to be less correlated. And that's what we term as weak instruments. Not weak, weak instruments. Your instrument is not strong. And the strong instrument is that the instrument that you use must be strongly correlated with the variable that you try to instrument. But if that variable is highly persistent, the instrument that you use will be weak.
Okay.
Right? So you have the problem of weak instruments in there. Once you have weak instruments, violate the conditions of next one, violate the condition of instrumental variables, what would happen? Again, your result may have problems. Right? May have problems. Next one, we have gone through first steps and second step. Next one, next. And that's right. You have the problem of weak instruments, but the other problem that you have is basically is this, right? When you take the first difference for you to make estimations, right? What do you do when you take the first difference? Remember one thing that when you work with data, right? So econometric very interesting because of this, right? A lot of things coming up that you have to think, right? Now, you are now working with data with I dimensions, with T dimensions. You have both cross-sectional unit, you have time series, right? Both of them. And we address some of the issues with this cross-sectional unit. For example, the problem of heteroscedasticity, right? We address by using two steps, estimation technique, right? Which means we incorporate not equal variance there into the estimations by using two steps. And we acknowledge the fact that they may problem, and then we use win measure corrections, right? In order to resolve the problems. But we also have time series dimensions. Now, when you learn time series dimensions, time series have 4 components, right, in time series. Right? At least 1 components are there. Right? They have trends, components, because when you look at time series, sometimes you have long trends going up, trends coming down over a long period. So you have trend components. And then you see cycle in there, kind of up and down. And for most panel data, you don't have these problems. But if you use quarterly or monthly data, you may have the problem of seasonal variations. Right? Seasons. And you have error component. But for us, normally we don't use quarterly data, we use annual data, so we don't have to worry about seasonal problem. But when you take the first difference, right, you look at, if your data look like this, when you take the first difference, become like this, right? When you take the first difference. So which means that when you take the first difference, you filter out the trends in your data set. You take out the trends. Now ask yourself, when you take something out, but if that's something important, what would happen? Right? Now, so you filter out informations which might be useful. Right? You filter out information that might be useful. So how to resolve that problem? Some suggest that why not we maintain both? Why not we use both the level equation as well as the first different equations and make it as a system? and run the estimations. Because we can filter out, but we maintain also the levels. And we estimate them together by imposing the moment's conditions, the instrument that we need, and so on, so that we are not going to lose information. And by doing that, it can solve the problem of weak instruments. And that comes, I think, 1988 articles, the system GMM. Right? So it's basically, they start with the first difference, but people find out the first difference might have the problems of weak instruments and the problem of taking out information from the data. Because as I mentioned, when you take the first difference, this trend can mean something to you. But you take it out. Like you do, for examples, time series. You just take the first difference, but then how about the level in data? If there exists co-integration, what would happen? You filter out something important, right? So as a result of that, you maintain both, which means you use both next ones, the level equations, and you use both the first different equations. And that one comes, the next one, what we term as system GMM, right? So you run both equations.
Basically, this is GMM based with your life problem, right?
With
my life problem.
No, your system GMM can resolve the problem of weak instruments, but not of too many instruments. Because once you have system GMM, you add more instruments into your equations. But it can resolve the problem of weak instruments and allow you to maintain the data as it is, so that you are not filtering out the trends out of your data set. Yeah.
What I'm trying to say is, like, I thought this is given. If you have less, they can have more because they have the internal instrument. But if you have more, they can limit. I thought that's the concept.
In terms of instrument, of course, they will have more.
Yes.
In internal instrument, but now because you have two equations, right?
Yes.
You have to have the instrument for the first difference, and you have the instrument for the level equations.
Yes. Also, they almost like they can limit, right? With the Avon.
Yeah.
Yeah, right. They limit the instruments, so.
And that's why you have to check whether the instruments are many or not.
Right.
And then you need to limit the instruments. But both of them can limit instruments. First difference or system GMM, both of them allow you to limit the instruments. But the benefit of system GMM, let me give you the benefit of system GMM. One, they resolve the problem of weak instruments. Second one, they maintains the level of the variables, which means that we are not filtering out this. We are not looking at this. We just incorporate this one in. So maintain the data, and we use them. And the third one with system GMM, which I would say very important in our line of research. We love to have dummy variable of Islamic banks, compliant firm, and so on. If you use first different GMM, you cannot include dummy variables. Time invariant dummy. Why? Because if I have Islamic bank dummy, which remain the same, if I take the first difference, what happens? Go to 0. But if that dummy variable is my key variable, I cannot run them. But system GMM allow you to maintain this. Why? Because you still have level equation that have IB in there, not filtering out, right? So system GMM help you in that context. And that's the reason why in most cases, when you read the article, normally they will use two-step system GMM. But I give you evolution from one step, two step, first different, and now system GMM. Also one step and two step. And why people use system GMM? Because of that weak instrument problems, because of want to maintain information in data, you don't filter them out, right? And it allows you to put in time invariant dummy variable like Islamic bank dummy. share compliant stocks, for examples. Right? Allow you to put that type of variable in your equations. And as a result, you can run them. Right? So you have both system and first different GMM. Right? So these are the method we can discuss later on in terms of the theories if you are not clear. But let me go to the next one.